Okay, now that we have finished talking about geometric vectors, it's time to look at algebraic vectors. You math-minded people are going to like this way a lot more, and some of y'all have already been doing it this way in your heads. So let's go ahead and take a look at it. You have two forms that you're going to see it algebraically. You have component form and linear combination form. They mean the same thing, they're just written a different way. So if we take, let's just make up a vector PQ. If I have PQ, that means your point for P has an X value and a Y value, and your point Q has an X value and a Y value. So to create the vector from your 2 points, you take your second point minus your first point to find that displacement. So the X value of Q minus the X value of P, and the Y value of Q minus the Y value of P. A vector uses these little arrow brackets. So once you subtract, you'll get some vector X value, some vector Y value. This is component form. Your X displacement, your Y displacement with these arrowed brackets. Linear combination form takes this component form, so I have my X and my Y values of the vector, and it just rewrites it as an equation. It takes that X value and puts an I next to it, and then says plus that Y value and puts a J next to it. This is linear combination form. So they both represent the X value and Y value of your vector. They're just written a different way. Another thing we will need in order to solve some of these algebraic problems is the equation for magnitude. We did this in our vector models where we basically took that Pythagorean theorem. So if you're trying to find magnitude, remember they use those double absolute values. So you'll be taking the square root of the X value squared plus the Y value squared. Just Pythagorean theorem, right? Cool. Okay, so let's use this information to solve some of these problems. Given points A and B, express vector AB in component form and then find the magnitude. So let me draw a picture. It says A and then B, so I know it starts at A, ends at B. A is -3, 5. B is 8, 12. So if I'm going to find vector AB, I am going to take the second X value minus the first, second Y minus the first. So I'm going to do 8 minus a -3 and 12, not comma, minus 5. Go ahead and subtract those. So 8 plus 3 is 11, 12 minus 5 is 7. Here is vector AB. Okay, but now to find the magnitude of AB, I'm going to take the square root of the X value squared plus the Y value squared. 11 squared plus 7 squared is 170. If I'm going to simplify that, that's only 17 times 10, so 17, 2, and 5 cannot be simplified. That's my answer. Remember, this component form is also considered direction, your X and Y direction. Okay, let's look at one in linear combination. So I have U is 3i minus 2j, V is -4i plus 5j. Since these are in linear combination form, I know that U and V are our vectors. They are not points, they are vectors. I want to find U plus 3V. Whenever I see linear combination form, it's easier to do the algebra if you switch it back into the component form. So for U, that's going to be 3, -2. And V is going to be -4, 5. Okay, so if I'm going to find U plus 3V, I'm going to take u, 3, negative 2, and add 3 times v. So negative 4, 5. So I just plugged in the values for u and v. First thing I'm going to do is distribute that 3. So that'll be negative 12, 15. Now, when you add two vectors together, we're going to add x plus x and y plus y. So 3 plus negative 12 will give us negative 9. Negative 2 plus 15 is 13. So here is u plus 3v. However, it also wants us to find the magnitude. So if I'm going to find the magnitude of u plus 3v, we are taking the square root of negative 9 squared plus 13 squared. Be careful if you're typing this in your calculator. If you don't put that negative 9 in parentheses, it will tell you negative 9 squared is negative 81. But we all know it should be positive. Your square root will simplify to 5 root 10. Okay, that's how you'll do algebra on some vectors. There's another vector that is called the unit vector. The unit vector is a vector in the same direction, but has a magnitude of 1. Okay, there are 2.5 steps to this process. So if you have a vector W, step 1 is to find the magnitude, because we need to figure out what the magnitude is so that we can make it 1. If it's already 1, then we're done. So to find the magnitude of W, we're taking the square root of 4 squared plus 5 squared. I went ahead and made that positive 5 because I know it's going to turn positive anyways. And I'll get square root of 41 there, and that cannot be simplified. So here's our magnitude. Step 2, we got to create our fraction. Our unit or our vector over its magnitude will create the new vector. So I will do, our x value currently is 4 over the magnitude root 41. The y value is negative 5 over the magnitude root 41. This is the unit vector. So that was 2 steps. Your half step, your optional third step, is to check that it equals 1. So to check our magnitude, we take the square root of 4 over root 41 squared plus negative 5 over root 41 squared. We type that in our calculator to see if it equals 1. And when you do, it does. So I know I found it correctly. So this is the unit vector for vector W. Okay, turn the page. A couple more things we want to see with algebra. If I have vector AB, and A is at negative 2, 4, find B. Now, the biggest mistakes here is we have a bunch of different parentheses, we have vectors, we have points, and people confuse the two. Remember, a vector has these arrowed brackets. A point has parentheses. So if our vector is A to B, I'm going to draw it, which means it starts at A, ends at B. A is not 3, negative 6. A is negative 2, 4. That's the point. They did not give me a point for B. We are trying to find B. So for right now, I'm going to make B x, y. We're trying to solve for the x value and solve for the y value. However, we know that the whole vector is 3, negative 6. So I'm going to use that process to create a vector to solve for x and y. Because to get our vector, we do the second x minus the first x, second y minus the first y. So for us, we're going to say x minus negative 2, so that'll be x plus 2, and then y minus 4, and it's supposed to equal 3, negative 6. So you're trying to ask yourself, x plus 2 equals 3. So we have to figure out what x is. And y minus 4 equals negative 6. Let's figure out what y is. If you solve those two problems, we're solving for point B. So we're going to use parentheses, not those arrows. And then 1 plus 2 is 3. And negative 2 minus 4 is negative 6. So B is at 1, negative 2. Okay, y'all try example 2. Pause the video, give it a try, and then we'll check our answer. Welcome back. Let's check our answer. So you would have drawn vector AB, gave A x, y this time, and we have B. So second point minus the first point. So 4 minus x, 10 minus y. We're creating a vector. And it should equal negative 2, 5. Did you get that so far? Great. So you're doing 4 minus x is negative 2. And 10 minus y is 5 to solve for point A. And you should have gotten 6, 5. Did you get that? Yay! Give yourself a high five. Okay, one more thing we're going to see, and you've actually done this in geometry before, but you didn't do it with vectors. It's going to be a little bit easier now that we have vectors. I have point A, point B, and I'm trying to find the point that's a fourth of the way from A to B. So what we're going to do first is find AB. What is vector? What am I writing? So the first thing we're going to do is let me draw what's going on. I have vector AB. A is at 1, 3. B is at negative 3, negative 5. And I'm trying to find a point a fourth of the way. Let's name her C. We don't know her. Okay, first thing is let's find vector AB. So if you do negative 3 minus 1, that's negative 4. Negative 5 minus 3, that's negative 8. However, I don't care about vector AB. I want to know AC. So I need to take a fourth of AB. If I divide it by 4, it'll be negative 1, negative 2. So that means that vector AC is negative 1, negative 2. This did not tell me my answer, though. I want to know who C is. So I'm going to go back up here and basically do this process where I don't know the second point, but I know the first one. So I'm going to be doing x minus 1, y minus 3. X minus 1 should give me negative 1. Y minus 3 should give me negative 2. Let me rewrite that ugly C. So who minus 1 is negative 1? 0. What minus 3 is negative 2? Positive 1. And there you have it. See you next time.